Today we will go over Lesson 13-1 Day 1, Right Triangle Trig. The first thing we are going to review is the Pythagorean Theorem, which states that in a right triangle, the leg squared plus the leg squared equals the hypotenuse squared. More often, you probably see this written as a squared plus b squared equals c squared, where c is our hypotenuse. To use this formula, the triangle must have a right angle. So we must have one angle that equals 90 degrees. Let's go over some examples. Number 1, a equals 4 and b equals 10. And then I know that c is my hypotenuse because it's across from my right angle. So we can set up an equation stating that 4 squared plus 10 squared equals c squared. 4 squared is 16, 10 squared is 100. So if we add those together, we get 116 equals c squared. To solve for c, we can take the square root of both sides. And let's round to the nearest hundredth. So we get 10.77 equals c. And then make sure you go ahead and rewrite your answer with the variable on the left. Okay, let's try another example. Number 2, we have one of our legs as 5, our other leg is x, and then I can see that my hypotenuse is 11 because it's across from my right angle. So we can set up our equation, x squared plus 5 squared equals 11 squared. 5 squared is 25. 11 squared is 121. So we're trying to get x by itself, so next let's subtract 25 from both sides. We get x squared equals 96. Then we can take the square root of both sides. So we get x equals 9.80. Next, let's review our trig ratios. A trig ratio is a ratio of two sides in a right triangle. So first, let's review sine. Using this phrase, SOHCAHTOA, hopefully these are coming back to your memory. Sine is represented by these first three letters here. So we have the O, which means opposite, and then H, which is hypotenuse. So we would write our ratio with opposite on the top, and then hypotenuse goes on the bottom. Next, we have cosine. So that is the CAH, where the A represents adjacent and H represents hypotenuse. So cosine of whatever angle you are looking for equals the adjacent side, or the side next to your angle, over the hypotenuse. Lastly, we have tangent, which is represented by this part, TOA, T-O-A. So the O represents opposite and the A represents adjacent. So we have tangent of our angle equals the opposite side divided by the adjacent side. Now let's practice applying these trig ratios by setting up the following examples. So number 4, the first thing we need to find is the sine of angle A. So since we're focused on angle A, I'm going to go ahead and circle that angle. Then I always like to label my triangle because I think it just helps get through these problems a little bit easier. So across from angle A, we have the number 12. that is representing our opposite side. Then we know that across from our right angle is always our hypotenuse. So that leaves us with 16, which is the leg that is next to our angle. So that is our adjacent side. So if we're finding the sine of A, we want to take our opposite side divided by our hypotenuse. So for this example, that would be 12 over 20, which simplifies to 3/5. So make sure you are always simplifying if you can. Next up, we need to find the cosine of angle A. So cosine is the adjacent side over the hypotenuse. So in this case, that would be 16 over 20, which simplifies to 4/5. Next up, we have the tangent of angle A. So we want the opposite side over the adjacent side. So that would be 12 over 16, which simplifies to 3/4. All right, up next, we have the sine of angle B, the cosine of angle B, and tangent of angle B. So since we were using angle A, and now we're switching to angle B, I'm going to erase my labels on my triangle. And this time I'm going to circle angle B. So now that would make 16 my opposite side. My hypotenuse is still 20 because it's always across from my right angle. So that means that my adjacent side would be 12. Okay, so if we're going to find the sine of B, that's the opposite divided by the hypotenuse. So in this case, we would have 16 over 20. That simplifies to 4/5. Next up, we have the cosine of B. Cosine, we take the adjacent side divided by our hypotenuse. The adjacent side is 12 and our hypotenuse is 20. That simplifies to 3/5. Lastly, we have the tangent of angle B. So tangent is opposite over adjacent. Our opposite side would be 16 and our adjacent side is 12. This simplifies to 4/3. Now would be a great time to pause this video and give the next example a try on your own. We're going to go through the same exact process as we just went through, just with a new triangle. So we're starting off with sine of angle A. So I'm going to go ahead and circle angle A and label my sides. Square root of 5 is our opposite, square root of 21 is our hypotenuse, and 4 is the adjacent side. So for the sine of angle A, opposite over hypotenuse would be the square root of 5 over the square root of 21. So this time when we simplify, we have to make sure we rationalize our denominator. We don't want to have that square root in the bottom of our fraction. So we multiply the top and bottom by the square root of 21. That gives us the square root of 105. So I just took 5 times 21. And then on the bottom, we get 21. Up next, the cosine of A, we want to take our adjacent divided by hypotenuse. So that would be 4 over the square root of 21. So again, we need to rationalize our denominator. So when we do that, we get 4 root 21 over 21. Up next, the tangent of angle A, our opposite over adjacent, would be the square root of 5 over 4. Okay, now we're going to find the sine of angle B, the cosine of angle B, and the tangent of angle B. So let's go ahead and relabel our triangle. So this time, 4 is our opposite. 21 is still our hypotenuse, square root of 21. And then the square root of 5 is our adjacent side. Okay, so finding the sine of B, we take the opposite divided by the hypotenuse. So 4 over the square root of 21. Rationalize our denominator. So sine of B equals 4 root 21 over 21. The cosine of angle B, we take our adjacent side divided by our hypotenuse. So that would be the square root of 5 over the square root of 21. Rationalize our denominator. And we get the square root of 105 over 21. Lastly, we have the tangent of angle B, so the opposite divided by the adjacent side, which is 4 over the square root of 5. Rationalize our denominator, and we get 4 root 5 over 5.